the next presentation, so we can try to stay on schedule and move and go do the presentation without 5 minutes time. So the first project is the awesome project sponsored by Frito-Lay, where they will talk about their project right now. And as we go on, I'll try to let you guys know that not into the way how the project is 5 minutes now. The 3 minutes now. And 3 minutes starts right now.
All right. Hello, everyone. My name is Arash Fan. These are my teammates, David Hunter, Stuart Young, Sherry Durzak, and Andrew Yin. Together, we are the computer engineering team for the Frito-Lay UTDesign project. Stuart is on the mechanical engineering side of the team. We do need a mechanical engineering side because this project is very complex, so we are a multidisciplinary team. Frito-Lay has these, what they call slicer heads. And as you can see in this picture over here on the right, the top right, it's that cylindrical, yellow, drum-like shape. These slicer heads have 8 individual gaps, right? And these gaps are what the potatoes go through to get sliced. Every now and then there's heavy stress on the slicer head during operation. This means that the gaps become misaligned, and that means that there is undesired chip thickness at the end of the line, and that leads to bad chip products, right? So every 90 minutes or so, they have their operators take these slicer heads off of the line. They'll manually adjust these gaps, and with these adjustments, because they are human, there's slight error, there is slight inconsistencies. So Frito-Lay has come to us, and they've told us to build an automated system that these operators can use to successfully adjust these gaps and help remediate the inconsistencies in these gap widths. As you can see, our prototype is right there. Just to start real quick, we have an indexing table. That's what the slicer head will sit on. Within that, there are 3 pneumatically controlled probes. These are digital length gauges that are pneumatically controlled. They have a resolution of 1 micron. In addition, there are 4 stepper motors that can be linearly actuated to engage and disengage certain bolts and screws that are necessary for the adjustment process. All of those components are controlled by a set of microcontrollers. In addition, we are planning to implement the user interface. It's a touchscreen user interface, and we also have a database that we're going to have implemented to collect data and view statistics, etc. Right now, we're in the testing phase of our project, which is pretty much consisting of taking measurements using the head. We can successfully set the head. We're experiencing relative deviations of about 1,000th of an inch. We're supposed to be meeting our target requirement of about 0.5 We think that this error is due to the differences in our measuring device and Frito-Lay's current measuring device. So we think that the next step in our process is to take our prototype onto their production line, set a head on their production line, use that head to cut potatoes and view the chip thickness at the end of the line. And with that said, I'd like to open the floor for questions. And if you guys like, you can see our poster at our poster session, and you can see the prototype in action.
So real quick, what did the different team members do from the project?
Sure, okay. Like I said, my name's Arash. I did most of the software and, component integration, if you will. This is David, if you want to go ahead.
David was team lead and also did some of the sensor analysis and choosing over that.
Stuart, I'm from the mechanical engineering team. On the mechanical engineering side, we designed the whole system that sits on, getting all the tolerances properly aligned and making sure that everything works properly.
I'm Cheryl. I'm on the CD team. I did all of the UI, and I also worked on the motors and controls.
Hello, my name is Andrew Yin, and I did most of the circuitry that our microcontroller interacts with.
Thank you.
What was your most significant challenge and how did you tackle it and did you solve it completely?
Let's see, the question was, what was our most significant challenge and how did we tackle it? Me personally, it's a very complex project in and of itself. There are a lot of different components, and merging all the components together was fairly difficult. The fact that you had to account for, real-time systems, you had to account for different communication schemes, you had to account for where everything was at once. And it's not so much a linear program as it is, combining all the integration as well. So that was a fairly difficult approach, as well as somewhat, our tolerances I mean, like, vibrations here and there can move it by about 1 or 2 microns, so I mean, like, establishing that tolerance was fairly difficult.
Did this team do all of the mechanical assembly, or did you inherit part of it?
So we, like I said, there was a team of 5 computer engineers and a team of 5 mechanical engineers. And mechanical engineers were responsible for making the structure. We started with nothing and we ended up with the structure.
So we designed how everything actuates, we designed how the arm would swing into place, we designed the parts that we needed to fabricate. Unfortunately, we couldn't fabricate these in-house because our machine shop was not ready, so we had to send that out.
But it's ready today.
Very good. Very good. Any other questions?
So I think that time-wise we are done, so any more questions can be
At the poster?
stop at the poster. Are you guys going to have the
Yes.
the driver
We should.
answer at the poster, so you can see it in action. No,
That-
not in action,
No, you can see it now. You can see it.
but without the paper.
Without potato.
All right, so